Right, okay, so here's the question from the homework, where we have got a question to use the central limit theorem. Okay, so a fair dice is rolled n times, so we don't know what n is. Given that there's a less than a 1% chance that the mean will differ from 3.5 by more than 0.1. So let's imagine this situation. So if we draw a bell curve, okay, and we've got 3.5, and then we've got 3.6, and then we've got 3.4. And basically that means that the whole of this area is going to add up to 0.1. So 0.01. So basically this part is going to be 0.005, and this is going to be 0.005 to give us our 1% chance. Right, but we need to find the minimum sample size because we don't know what n equals. Okay, well, normally if we've got an area but we don't know the value, if it's a normal, we can do a reverse normal. But we don't know what the mean or the standard deviation are. So first thing, let's work out what the mean is. So the mean we could also calculate as the expected value of rolling this fair dice. So we know the expected value is equal to the value x times its probability, and then the same thing, x plus, but basically that's just going to be 1 over 6 times 1 plus 2 plus 3, because each one's multiplied by a sixth, plus 5 plus 6, which is going to give us 21. So give us 3, 6, 10, 21 over 6, and that is equal to 3.5. Okay, so that's my mean. Okay, now I need a standard deviation. So what I'll do is I'll do the expectation of s squared. And again, remember, this is 1/6 times the value squared. So that's 1, 4, 9, 16, 25, 36. And that gives me 91 over 6, which is equal to 15.16 recurring. Okay, now I want the variance, and that is equal to the expectation of s squared, 15.16 recurring, minus the expectation of x, or s, sorry, all squared. And when I subtract those, I get 35 over 12. Okay, so that is basically, that is my standard deviation squared. So my standard deviation is equal to the square root of 35 over 12. Right, now we can think about using the central limit theory. So if I take the average of my means, okay, and they'll be normally distributed with a mean of 3.5 and a standard deviation squared of 35 over 12 divided by n. And n is the thing that I don't know. Right, now what are we trying to do? We're trying to find the two areas above. Now, because that curve is symmetrical, that means that the two areas we've marked are equal. So what I can just solve is the probability that my mean is going to be greater than 3.6, and then that area has to be less than 0.05. Okay, so I need to find a value that makes that true. Right, so I'm going to go to the my standard normal table, and my standard normal table tells me that of z value of 2.5758 is equal to 0.005. Right, now remember the formula for this. So I want the probability that S is greater, S bar, is greater than 3.6. So I'm going to standardize this to make it a standard normal. So my Z, therefore, has to be greater than 3.6 minus the mean, which is 3.5, all divided by my standard deviation, which is 35 over 12n. And we worked out the value, so Z is greater than 0.1 over the square root of 35 over 12n, has to be less than 0.005. Right, so that means I know what I want. My Z has to be greater than 2.5758 according to the table. So now I can basically put my equation together to solve for n, because n is my unknown. So 0.1 over the square root of 35 over 12n has to be greater than my Z value, which is 2.5758. Well, I've got a decimal divided by a fraction effectively. So that's 0.1 over the square root of 35 divided by the square root of 12n. Well, we know if we divide a fraction by something, we basically just multiply, we flip it. So basically we're going to have 0.1 times the square root of 12n over the square root of 35. And again, I can simplify that because 0.1 is actually a fraction. And I'm multiplying my fraction square root by 1 over 10. So I can rewrite that as 12 over n. So 12 square root of 12n over 10 times the square root of 25. Right. So now square root of 12n over 10 times the square root of 35 is greater than 2.5758, and therefore if I square both sides, 12n over 3,500 is greater than 6.63474, and again I multiply by 3,500 divided by 12. That means that n is greater than 1935.13. So that means that n has to be 1936 because it's a sample size and I need a whole number. And that is the answer to question 8.